This is the Arete Labs from Thursday, December 10th.
Today's Thursday.
Yeah, today's Thursday. That is right.
Were you filming? Is that why you said that?
Yes, that is correct. So the basketball coach of the team wants each player on the team to make at least 75% of the free throws attempted during the regular season games. Currently, player Ortiz has attempted 30 free throws and has made 21 of them. How many free throws must Ortiz make in the next 10 attempts to reach the coach's goal?
All right. So, 21 divided by 30 is like 0.7, so we know that he has made 70% of his free throws so far, but he needs to make 75% of 40, which is 30.
And how'd you get 40 attempts?
10 attempts plus 30.
10 plus 30. So we have 40 total attempts, okay.
And 75%, so the target goal is 75% of that. So 30, he needs to make 30 free throws. Right now he's made 21, so in his next 10 attempts to get to 30, he needs to make 9.
Right, because 75% is 30 out of 40, and so you're right, he needs to make 9 more. Because 9 plus 31, or 21 is 30. All right, for number two is a wee bit trickier. And we're going to use some magic from the rules from irrational numbers. All right, so the first thing I know is that 176 can be broken into, or the square root of 176 can be broken into square root of 11 times the square root of, how many times is 11 going to that? 1, 6, 6. Is that right? No. That is clearly not right. 16. So what is the square root of 16?
4.
4. So we know that 4 times the square root of 11 is equal to the square root of 11 plus the square root of something. Right? Now, we can only add irrational numbers. We can only add square roots if the what's underneath the square root is identical. So we know that it has to be some sort of 11ths, right? So,
yeah.
Yes, okay. So the question is, how many 11ths? So right now, I have 1 square root of 11, and I'm adding some number of square root of 11s to get to 4 times the square root of 11. So that means that the square root of x has to equal 3 times the square root of 11, because 1 of the 4 over here is taken up by this one right here.
Okay.
So, all right, well, that means that for this piece right here to be x, or well, actually, better yet, here's a better way to explain it. What's the opposite of square rooting something?
Square second power.
Right, so we will square both sides. So we get x is equal to 3 squared is 9. Square root of 11 times the square root of 11 is 11. So 9 times 11 is 99.
99. That was fairly simple.
Yeah, it's not too bad. But the trick on that one is realizing that you need to break this apart and going from there. Let's go. In the figure ABCD, ABCD is a parallelogram, and triangle BCE is isosceles with BC is equal to EC. So let's write that down. BC is equal to EC. Given that angle DAB is equal to 75 degrees, and that's already written, what is the angle measure of angle BCE? So that is BCE. So it's this one right here. All right. Oh yeah, this one is not terribly bad. Okay, so how do you do this?
So first, because it's a parallelogram, the A, B, C, D is a parallelogram. I knew that BC was parallel to AD, and therefore angle EBC is a corresponding angle of angle BAD. So angle EBC is also 75 degrees. And since it's an isosceles triangle, angle BEC is also 75, or Mr. Frampton, EBC is 75.
E?
BC.
How do you know that's 75? Oh, because they're parallel, so that's 75. Okay. All right. So you know that's
And then-
75 too, right?
Yeah, and then 75 plus 75 is 150, and to complete a triangle of 180 degrees, the next angle will be 30. So BCE is 30 degrees.
All right. Brilliant. Okay, how about number 4? On February 10th, the sun rises at 7:10 a.m. and sets at 5:14 p.m. Each day after that, through February 18th, the sun rises 4 minutes earlier and sets 5 minutes later. From February 10th through February 18th, what is the average time in minutes between sunrise and sunset?
640 minutes, because the answer is showing.
Ha 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 ha.
No. So first you gotta list out all the days, or at least this is what I did: 10, 11, 12, 13, 14, 15, 16, 18. And then the starting times. And then first I listed all the sunrises starting at 7:10. Then I subtracted 4, got 7:06, then 7:02, then 6:58, then 6:54.
Well, wait a second. So on February 10th, how many days of sunlight are there?
There are minutes. I think it was 604 minutes.
And how'd you get that?
Because it's 10 hours and 4 minutes, which is 604 minutes, because 10 times 60 is 600, and then you have the extra 4 from the difference in minutes.
Okay. So how many minutes of sunlight do you have on the 11th?
613 minutes.
How'd you get that?
Because subtract 4, you get 706, and 719, and then you get 10 hours and 13 minutes. And then that pattern continues, and it's 9 more through each one.
Right. So you're adding 9 minutes per day. Okay. So that's 22. So 9 more minutes is 6:31, 6:40, 6:49, 6:58, 6:67, and 6:76. All right.
And then you add all those together and divide it by 9, because that's the number of days. You get 640 minutes.
Or you could just look at the day that's in the middle.
That would work.
Wait, would there? So if you wanted to, you could only pick 14 and just do everything for 14 instead of doing everything out, right?
Yeah. So because you know that it's a linear growth model for these 9 days, and so the average time that is going to be sunny is going to be the middle day, and since 9's an odd number, there is one day that's in the middle, and so that's how you can get that right there, 640. All right.
Yes, please.
All right, so James is pulling a toy, or pulling toys out of his toy box, either 2 at a time, 3 at a time, or 4 at a time. How many ways, including order, can you pull out a total of 8 toys in this way? All right, so in this case, I do like to make a list, and I like to start with the most possible toys taken out at once. So let's figure out how many different ways he can take out 4 toys. So if he takes 4 toys out on his first pull,
2, 2, 2, and 2.
and 4 in his second pull, he gets to his total of 8, right? Now, if he pulls out 4, then he could also do 2 and 2. How else can he pull out toys to a total of 8 if he starts with a pull of 4 toys? Hello? Okay, how about 4, 2,
none.
1, and 1, right?
Wait, he can't pull out 1. He can't pull out
Oh,
1.
he can't pull out 1? Oh, okay. Okay, so we can't do...
That's all the combinations.
Yeah, okay. So then, yeah, you're right, because there's no 1. All right, so then let's start with 3. So we could go 3, 3, that would be 6 and 2, right?
You can also do 3, 2, 3, and 2, 3, 3. You can also do 2, 4, 2, and 2, 2, 4, because it's including order.
Okay. All right. And also we can go 2, 2, 2, and 2, right? Yes. No. Maybe so. So that's a total of 1, 2, 3, 4, 5, 6, 7, 8. And we can't do any one without doing ones. That really limits us. So we're down to a total of 8.
And that's the answer.
That's the answer. All right. So this next problem is actually kind of counterintuitive. So here's the thing. The stock market has been really volatile in the past 2 days. Yesterday it rose by X%, and today it fell by X%, resulting in an overall loss of 64%. What is X? Now, here's the thing. If you go up by X%, that means when you fall by that same percent the next day, that fall is going to be greater than the rise because the number that you're taking the percent off of is a larger number to begin with. So you can't just say X is 64% because after you apply this first rise, the new number that you're taking the percentage off of is going to be much bigger. So that's not going to work so well. So if we lose 64%, what percent remains?
36.
So we know that at the end of the day, we are going to have 36 out of 100, right?
C.
Say yes. Okay, good. All right. So then on the first day, it goes up X%, right? So that's going to be, so if we're at 100, it's going to go up by, we're going to multiply it by 1.x. I'm getting a little confuzzled. Hold on a second.
100. Wait, wouldn't it go down X% from the previous day? Or
Yeah.
is the end of the previous day considered 100%?
Well, so we're multiplying it together so that we're multiplying this negative, this percent loss, this less than 1, by what we had from the rise. So we should end up okay, right? Maybe?
Or what I'm saying.
Did anyone get
All right.
this?
So here's the thing. So 100 times 100 is
10,000.
100 plus x times 100 minus x. Well, this is straight out of what we're doing in 8th grade math, isn't it? If I were to write this,
Oh yeah, this is.
One a quadrat. Oh.
So it's 100 to the second power minus x to the second power.
there you go. And so that's going to equal 36 over 100. But
You multiply them both by 10,000.
But wait a second. So we could do a cross multiplication thing. That's going to get pretty ugly. But I could multiply 36 over 100 by 100 so that I have a common denominator, right? So that's going to give me 100 squared minus x squared, and that is going to equal
36.
right. And obviously this is all over 10,000.
It does not technically cancel out.
But it cancels out because I could multiply both sides by 10,000. All right, so, okay, now this is starting to get easier. So 100 squared is 100
Wait,
times...
that's a difference of squares.
I
Yeah,
know, Walter.
it is a difference of squares, and we had to
Oh,
expand...
we just could not though, so we wouldn't put it back to where it was.
Right, exactly. We don't want it. Right? So then 100 squared is simply what?
10,000.
10,000. So 10,000 minus x squared is equal to 36. So then
Wait,
so
might it be better if we? Oh, never mind.
So if we add x squared to both sides, we'll get 10,000.
3,600 plus x squared.
And then should we subtract 3,600?
There you go.
64,000.
Wait, that's like 80 or something, isn't it? Or 800. Wait,
So the opposite of squaring something is square rooting. So the square root of x squared is x. The square root of 64,000 is 80.
Yep, that makes sense.
is it? I thought it was. Oh,
Yeah, you're welcome to have a seat.
square root of
All right.
64.
A quick little note. I have too many zeros here. 10,000 minus 3,600 isn't 64,000. It is actually 6,400. And then the square root of 6,400 is in fact 80. So Walter, you got it.
Yeah.